Water and water resources is very important for maintaining an adequate food supply and a productive environment for all living organisms. Here are the properties of water that have management application. Polarity, boiling and freezing point, specific heat capacity, density, surface tension, heat of vaporization, vapor pressure, viscosity, capillary action, cohesion, solid, liquid, and gaseous state. The molecular makeup of water or polarity. Water is a simple molecule composed of two small positively charged hydrogen atoms and one large negatively charged oxygen atom. When the hydrogens bind to the oxygen, it creates an asymmetrical molecule with positive charge on one side and negative charge on the other side. Boiling and freezing point. The water has an incredibly big boiling point, which is 100 degrees Celsius. This is because water requires more energy to break its hydrogen bonds before it can then begin to boil. The same concept is applied to the freezing point. The boiling and freezing points of water enable the molecules to be very slow to boil or freeze. This is important to the ecosystems living in water. If water was very easy to freeze or boil, drastic changes in the environment would affect bodies of water such as oceans or lakes, and causes all the organisms living in the water to die.
Specific heat capacity is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. The specific heat capacity of water is much higher than that of other common substances. For the sake of comparison, the specific heat capacity of oil is about 0.5 cal and the specific heat capacity of aluminum is about 0.2 cal. The high specific heat of water helps the Earth's temperature remain moderate since water traps heat during the day and releases it slowly at night. Density is the ratio of mass to volume, and dense objects feel heavier and tend to sink, while less dense objects feel lighter and tend to float. The density of most objects changes slightly as the temperature changes. In general, warmer temperatures tend to make substances less dense because the greater random kinetic energy makes the molecules spread out. The amount that objects expand when heated is known as the coefficient of expansion.
Surface tension. Water has the highest surface tension for all liquids. Surface tension is the property of the surface of a liquid that allows to resist an external force. So these forces vary depending on the nature of liquid or solutes in the liquid. Surface tension is a measurement of the amount of force to break the skin on the surface. Other liquid has a surface tension as well, but in water, it's quite strong due to the hydrogen. Pressure is inversely related to intermolecular forces. The stronger forces have a lower vapor pressure, where water has a very strong intermolecular forces. Viscosity is the property of fluid having a high resistant flow. Liquid like honey or motor oil being viscous, but compared to other substances, water is viscous. Liquid with stronger intermolecular interactions are usually more viscous than liquid with weak intermolecular interaction.
Cohesion. Cohesion is the force of attraction between the molecules of a substance. The thicker or more viscous fluids have more attraction between their molecules, or they have greater cohesion. Cohesion holds the molecules of water together, which is not present in the case of gases, which is why gases spread away. For example, water droplets are also the result of cohesion between molecules of water. Solid state. All substances, including water, become less dense when they are heated and more dense dense when they are cold. So if water is cold, it becomes more dense and forms ice. Water is one of the few substances whose solid state can float in its liquid state. Why? Water continues to become more dense until it reaches 4 degrees Celsius. After it reaches this temperature, it becomes less dense. When freezing, molecules within water begin to move around more slowly, making it easier for them to form hydrogen bonds and eventually arrange themselves into an open crystalline hexagonal structure. It is very rare to find a compound that lacks carbon to be a liquid at standard temperatures and pressures. So it is unusual for water to be a liquid at room temperature. Water is liquid at room temperature, so it's able to move around quicker than it is a solid, enabling the molecules to form fewer hydrogen bonds, resulting in the molecules being packed more closely together. Each water molecule links to 4 others, creating a tetrahedral arrangement. Gas state. As water boils, its hydrogen bonds are broken. Steam particles move very far apart and fast, so barely any hydrogen bonds have the time to form. So, less and less hydrogen are present as the particles reach the critical points above the steam. Lack of hydrogen bonds explains why steam causes much worse burns than water. Steam contains all the energy used to break the hydrogen bonds in water. So when steam hits your face, you first absorb the energy the steam has taken up from breaking the hydrogen bonds in its liquid state. Then, in an exothermic reaction, steam is converted into liquid water and heat is released. This heat adds to heat of boiling water as the steam condenses on your skin.